on to problem number 7 in the review. It says solve each system of equations using any method. You could get a system with 2 variables, but you could also get a system with 3 variables. Okay, so something we're going to review right now is how to use the matrix to help us solve this. If I was to do problem number 7 by hand, I would probably use the substitution method, because what does it say x is equal to? X is equal to what? Y plus 2. So instead of 3 times x, I would put 3 times y plus 2 minus 2y equals 5. Distribute 3. You get 3y plus 6 minus 2y equals 5. And I don't know why my board is acting up right now. Maybe because it knows I'm recording. Come on, settle down, board. You're acting like a teenager. There it is. Alright, here we go. So, 3y minus 2y gets me a y. So I have y plus 6 equals a 5. And all you have to do is subtract 6 from each side, and you get y equals -1. The cool thing about the substitution method is you can take that -1 for y and plug it right back into the equation for x, because what is x equal to? X is equal to y plus 2, and x equals -1 plus 2, so what is x equal to? Positive 1. And that's just doing it by hand using the substitution method. But it says solve each system of equation using any method. So what if substitution is just not your thing? That's okay. We can still use the matrix to help us solve the problem. You could use Kramer's rule. You could use inverse matrices. My suggestion, use inverse if you have a calculator. All right, and I'll show you how to set this up in the matrix and use the calculator. All right, so I'm going to clear this out. Right now, the first equation is 3x minus 2y equals 5. We already know the answer to this. We're just doing this to show you how to use the calculator. By the way, I have to rearrange this, don't I? The x is on the left side of the equal sign, but to move the y across, that would become the opposite. So if you ever need to move something across the equal sign, you got to make it the opposite of what it is. So we've got x minus y equals 2. Let's remember how to set this up. I'm going to say matrix A times matrix X is going to equal matrix B. I'm going to put my X and my Y here. To set this up, it's a 2 by 2. Put a 3, a -2, a 1, and a -1. So you take these coefficients, 3, -2, 1, -1, you put them in matrix A. What numbers go in matrix B? 5 and 2. 5 and a 2. Just remember, matrix X, which is this X and Y, is going to equal the inverse of matrix A times B. And that will give us our answers of X and Y. Now, if it was a 3 by 3, I would definitely probably use this method if I had a calculator, all right, to find the X, the Y, and the Z. So let's just do the calculator. Now, get your calculator, turn them on. All right, I'm going to turn my calculator on. I'm going to hit second plus 7, 1, 2, just to clear everything out. All right. All right, to edit my matrix, you hit second, x to the -1. You move to the right arrow twice. You press enter. We need to make it 2, 5, 2, enter. And then we're going to type in the numbers that go with it. So let's think about what our numbers are. Our numbers go back here. Look at our matrix. We've got a what? A 3, a -2, a 1, and a -1. So I'm going to go back to my matrix. All right. 3, -2, 1, -1. So I type those in. Now matrix A has been edited. Go second. Matrix go to the right where it says edit. Now you're going to go down to number 2, and you're going to make a 2 by 1. Was it a 5 and a 2? Was it a 2 and a 5? 5 and a 2? 5 and a 2? Okay, 5 and a 2. That was matrix B. Once you have matrix A and matrix B all taken care of, second mode, we're going to take second x to the negative 1. We're going to select matrix A, but we're going to actually raise it to the power of negative 1 to make it its inverse times second x negative 1, 2. Now, if you don't know why this works, there's another video you could watch about identity and inverse of matrices. All right, how to solve it. Press enter, and what do you have? The answer. This is your x, and that is your y. So your answer would be 1 and a negative 1. Okay? So if you were to go back, I did the substitution method, right? And what did we find? From x was 1 and y was a negative 1. Just know, on your assignment, or your test that is, for number 7, you would write x is 1, y is negative 1. Okay, there's your x, there's your y. So let's look at number 8. We're not going to do the whole method again, but let's look at number 8. It's pretty much set up for us, isn't it? So right here. Now you could use the elimination method to do this, okay, as well. But I'm just going to write a 2, a 3, a 3, and a negative 2. And I'm going to call that matrix A times matrix X, which is X and Y. And set that equal to a 5 and a 1. And once again, what's the formula? X equals the inverse of A times B. Is there any reason for any student to miss this problem? No. But they will. They really will. They're really working hard. If not, no. Now, this one's actually turned out to be pretty easy. You could probably do this without even using the matrix if you just looked at it carefully. It's going to be a 1 and a 1. And it kind of makes sense. Look, if I plug in a 1, if I plug in a 1 right there, 2 times 1 is 2. 3 times 1 is 1. What's 2 plus 3? 5. Plug in a 1 there, plug in a 1 there. 3 minus 2 is also 1. So you can kind of look at that one and kind of pretty much figure it out without having to do a whole bunch of work. Right? But you're going to need to know how to use the inverse, because I'm just giving you a hint. Everybody, since you're watching this, okay, you got an x, a y, and a z. All right? So that's how you use the inverse properties of a matrix to solve for x and y.